Well, hello, ladies and gentlemen. Let's talk about the types of systems of equations and how you stumble across them algebraically. Graphically, pretty easy to know, right? Like if they cross in one spot, you have a good deal. You have one solution, consistent system. If they're parallel, none, right? No solutions. It's called an inconsistent. If the lines coincide, that means they're exactly the same line. There's infinitely many solutions. Those are called consistent dependent. But how does it look algebraically? So let's go ahead and let's explore that. So here's what happens. When you have this kind right here and you go ahead and you just do this, you solve it algebraically, you're going to end up with something that just works. So like, for example, here I would use substitution. So I'm going to take that value, I'm going to plug it in right there. 3x plus 2, 2x plus 4 equals 6. And you solve that, right? So you're going to get 3x plus 4x plus 8 equals 6. I'm going to go kind of quick because I would hope that you got the idea right here. So you get x equals negative 2 over 7. That's an ugly answer, but that's how it works. And then you take that value, you plug it in to the other equation, and boom, you got it, right? So let's go ahead and do it anyway. So y is equal to 2 times negative 2 over 7 plus 4. So y is equal to negative 4 sevenths plus 4. 4 is, of course, 28 sevenths, right? So y is equal to 24 sevenths. So our solution to this one would be negative 2 over 7 and 24 over 7. That's super ugly. Just made up the numbers. I knew it would have one solution, but yeah, kind of ugly, but that's how it works, right? And we ended up with y equals a number, x equals a number. That's our one solution. Boom, done. Now, algebraically, these other ones are going to be a little bit easier, but you might lose some confidence because you might think you did something wrong because weird things happen. So let's see this one right here. Let's do substitution again, right? So we've got 2x minus 4, and then we're going to plug this in right here. Yeah, just like that. So 2x minus 2x plus 16 equals negative 20. So look what happens when you combine like terms right there. 2x minus 2x is 0. 0x is just 0. So you have 0 plus 16 is equal to negative 20. That's a false statement. We didn't do anything wrong. It's just false. What that means is there's no number you could put in to this system right here. There's no number that you could plug into this system and it would work. These two lines are inconsistent. It turns out that they're parallel. There's no solution. They never ever cross. That's what it looks like. You end up with a number equals a different number that's not true, and that's what it means. All right, last one. I'm going to do this one by substitution as well, right? So let's say I didn't recognize that these are going to be coinciding. They're the same exact line, and I'm going to go ahead and do it. I'm going to take, that's why I'm going to plug it in, right? So 3. All right, so 9x minus 9x. Negative times a negative is positive. Look at that. That is equal to 0 again. 0x is just 0. So we end up with 0 plus 3 equals 3. That is a true statement. That means that, well, that's true, right? So that means that there's infinitely many solutions. Those two lines coincide. So anyway, that's how it works. I hope that's been helpful, and you guys have a wonderful day.